All right, welcome to the engineering technology class for October the 14th. Before I turned on the recording here, we were talking about the assignment that's due today, the Be the Robot activity. There's a few students who aren't here today, so I'm going to say again to the recording here what I said just a minute ago and maybe elaborate a little bit. So if you're one of the students who didn't complete the activity, you need to work with me to figure out why not. If you go through everything really, really carefully, you will get the right answer, but I will admit there are a lot of places where it's easy to screw up. So if you're having trouble, send me an email and we can set up a time where we go through it together to figure out why you're not getting it. But for today, I think it's really important that we move into the new material because today we have a lot of new stuff that's very important that I want you to get. And what we do today, we're going to be using the drag and drop software. So even if you don't understand all the little intricacies that apparently are tripping some of you up on the Be the Robot activity, that's okay, because what we do today is we're going to use the drag and drop software. So you should all be able to get it fine. All right, let me share the screen with you so I can show you here. So when we did the code.org activity, okay, what you did was the first time through, you used this stuff that you see over here. This is what I call the drag and drop. So this used what we can maybe call human language rather than computer language. So this used things like said, repeat 4 times. And we didn't have to worry about all this stuff in here. This is the stuff that is probably confusing you because there's a piece here that tells what is the name of the variable that keeps track of how many times we've been through the loop, and it initializes the variable. There's the piece here that is the test that we conduct in order to see whether or not we keep going through the loop. And there's this thing right here that tells what do we do to the variable that's keeping track of how many times we've been through the loop. This stuff right here, I can understand why some people might have a little bit of trouble with that, okay? But the drag and drop stuff, that's something that I hope everybody gets without any trouble. In fact, let's take a little poll here. What I'd like you guys to do is type into the chat box in a private message, so that way you don't need to be worried about being embarrassed. So in a private message to me, I want you to type either yes or no, where yes means that I understand the drag and drop. Now, notice I'm not talking about the real code. I'm talking about the drag and drop. So if you understand the drag and drop, type yes in the text box. If you're still having trouble with the drag and drop stuff, then type something other than yes. All right, I'm seeing a whole lot of yeses. Okay, good. All right, so tell you what then, let's kind of put all this other stuff. This is what I call the real code. Okay, let's put that on the back burner for a little while. And let's just focus on the drag and drop. Let's make sure that we can do the drag and drop right. Except what we're going to do today is not the Angry Bird stuff. What we're going to do today is, let's see, hang on a second here. Let me get into here. I'm going to share a screen with you, but I need to get it ready here. All right. So we're going to do something that actually accomplishes a useful job. Was that okay? I see somebody's there. I'm going to mute you all here because somebody there is unmuted. Okay, that'll. All right. So what we're going to do today is something that actually accomplishes a useful task that could benefit society. So let's go into the engineering technology tab. To-do is taking a little while to come up. Okay, let's go down and open up the assignments, quizzes, tests thing. All right. Okay, and now let's go down to computer engineering. So you'll see that we have a new assignment here that wasn't here before, and a couple important things about it. One, I want you to note that it counts the same as a midterm exam. Oops, 50 points. Sorry, I made a mistake there. That's supposed to be 100 points. I forgot to edit that. So hang on a second here. You guys can see how it is that teachers edit things while I go in really quickly here. That's supposed to be worth 100 points. So let me click here and go in and make it be worth 100 points. Okay. So this counts the same as a midterm exam counts. All right. And then the other thing that I want you to notice is when it's due. So if I turn on my annotations again and get rid of that, okay. So notice that it's going to be due on October 22nd. So that gives you more than a week to do this activity. So if what we do today seems a little bit overwhelming, remember, you've got plenty of time. You don't need to finish it today. All right, so this is an electric circuit that probably means absolutely nothing to you right now. This uses a special kind of a circuit board called an Arduino. And then over here, we have a bunch of interesting things. We got resistors and we got lights that are called LEDs. They're a special kind of light. And we got switches here, and this thing up here is a buzzer. So I'm willing to bet that all of this stuff right here makes 0 sense to most of you. But there might be some of you that have actually worked with Arduinos before. So let me pause for just a second, and I'd like you to type into the chat box, and I don't care whether it's a private message or a public message. The question I want you to answer is, have you ever done any work with an Arduino before? So the name of this thing is Arduino. Okay, so I'm not seeing any yeses at all. Okay, so none of you have ever done anything with an Arduino. Okay, that's fine. That's actually what I expected. No trouble at all. Okay, so what I'm going to do then is I'm going to explain things starting from the very, very basics. So an Arduino, you can think of it as a very small, very simple computer. And in fact, here it is. This is an Arduino. And it's got a bunch of pins up here, a bunch of holes up here. And you can plug wires into these holes. And it's got a bunch of them down at the bottom too. So you can plug wires into the holes here. And then this chip that you see right here, this chip, this is a special kind of computer chip that you can program it so that it does what you tell it to do, provided you use the right syntax. Remember what syntax means? It's the words and the commas and the semicolons, and it's all the rules for how you have to word things in order for the Arduino to understand it. Okay, so what I've got here is this is the Arduino, and you can see I've got wires that come out here, or maybe they go in, and they connect up these lights here. Let me zoom in just a little bit here, make it a little easier to see what's going on here. Okay, so let's suppose that we want to tell the Arduino to turn on this light bulb right here. So that's a green light bulb. And I want to tell the Arduino to turn it on, right? So what I can do then is if I follow along this wire here, this is the electrical wire that is connected to the green light bulb. And if I come down here, I can see that it is connected to pin number 7. So each of these pins here has a number. So the green light bulb is plugged into pin number 7. So if I want to turn on the green light bulb, what I can tell the Arduino to do is activate pin 7. Or maybe I would say turn on pin 7. Or maybe I would say set pin 7 to high. So I don't want to get bogged down in the actual syntax right now, but somehow or other, we are going to tell the Arduino to activate pin 7. And when we do that, then what will happen is pin 7 will we'll have electricity on pin 7, which will cause the light bulb to light up. Okay, and let's suppose that we want it to blink. Let's say we want it to blink once every second. So then what we would do is we would tell the Arduino, we would say, activate pin 7, wait for 1 second, and then deactivate pin 7 and wait for 1 second, and then repeat that over and over and over and over again. So then you can see what would happen. All right, well, what if it's not the green light bulb that we want? What if it's the red light bulb that we want? Well, what we can do then is we can just follow this line to see which pin is it connected to. So it looks to me like it's pin 5. So what we would do then is we would tell the Arduino to activate pin 5 and then wait for however long we want it to be on. And then we would say, all right, now deactivate pin 5 and then wait for however long we want it to be off. And then it'll just repeat that cycle over and over and over again. Okay, hopefully that makes sense. Now, the thing that you see in the upper left here, that is a buzzer. And if you follow the line that comes out here, you'll see the buzzer is connected to pin 11. So if we want to turn on the buzzer, what we'll do is we'll tell the Arduino, activate pin 11, and then wait for however long we want it to buzz. And then we'll say, okay, now deactivate pin 11. So you see how this works? Arduinos, by connecting them up this way, they can do amazing things. We can hook them up to lights, we can hook them up to buzzers, we can hook them up to motors. We can also hook them up into sensors. So this guy right here is a switch. It's an electrical switch. So think of it like it's the light bulb on your wall, but it's one that only activates when you push it. So when I push that button, what it does is it will allow electricity to flow through. And so what we're doing now is instead of using these pins as output pins, we're going to use pin number 2 here as an input pin. So instead of telling the Arduino to activate pin 2, what we're going to do is we're going to tell the Arduino to look at pin 2 and see, does pin 2 have electricity on it, or does it not have electricity on it? And then what we can do is we can use the if statement, and we can say something like, if pin 2 has electricity on it, then turn on the green light by activating pin 7. And we can say, if pin 2 does not have electricity on it, then don't activate the green light, but instead activate the yellow light. Okay, so you see how pin number 2 could be used as an input. And the neat thing is that all of these pins, they could either be used for input or for output, depending on how you set things up. And as we go on for the next week or two, we're going to learn exactly how to do that. But we're going to start off really simple. Okay, so give me some yeses or nos. Please type into the chat box. Everything we talked about so far, does that make sense or does it not make sense? So give me yeses or nos in the chat boxes. Okay, good. All right. Glad to see it makes sense. Okay, so now let's go back to here. Okay, so when you click on this activity in Canvas, right, what you're going to see is the name of the project, okay? And so this is our first real true software engineering project. Do not forget, this counts as a midterm exam. So this is really important. If you blow this off, you know, you're not going to pass the class. You got to do it. Now, normally what I do is I verbally tell you what I want, and you guys have to write a functional specification. You guys have had a lot of practice doing that. Well, this time I'm going to do it a little differently. This time I am going to write the functional specification for you. So if you scroll down to the lower here, here is the functional specification. So this, what you see right here, these are the words that tell you what is the job that you need to do. But you'll notice that I haven't told you how to do the job because, of course, that's the way functional specifications are supposed to be. All right, so let's go through this. So the picture above shows an electrical circuit that runs traffic lights at an intersection, but here's the important thing. This is an intersection where blind pedestrians sometimes need to cross the street. In fact, let me zoom this up just a little bit more, make it a little easier for you to read. Okay, so we've got a traffic intersection here and we've got blind pedestrians who need to use the street. Okay, now you don't need to worry about how I created the circuit. You don't need to worry about how I connected up the lights and all those other things. That's called electrical engineering. And we are going to be learning about electrical engineering, but not until we finish this software engineering project. So I've done the electrical engineering for you this time. All you have to do is the software engineering, and then later you're going to learn how to do the electrical engineering. Okay, so there are two sets of traffic light signals where each set has a yellow, a green, and a red light. Okay, so you see here how it works. So these three lights together are one traffic signal. So this is a red light, and this one here may not look like it's a yellow light, but once it lights up, you'll see it is in fact yellow. And then this one's here is green. So these all together make up one traffic signal, and over here we have another traffic signal, right? So these are the things that need to come on and behave exactly like the traffic signals that you guys are used to. This thing right here is a switch, and we've already talked about how it works. So if I push the button, then it allows electricity to come up into the signal. And if I'm not pushing the button, then it does not allow electricity to come up. And now I've got this wired such that when we push this button, there's a blue LED that will automatically light up. And it doesn't light up because the Arduino told it to. It lights up because I've got the hardware wired that way. So even if we didn't have an Arduino here, when I push that button, that blue light would still light up. And the reason I did that is because I want confirmation. When I push that blue button, I want some confirmation that the blue button got pushed. So I want that light to come on. All righty. So now that you understand that, let's go back down here again. Okay, so your job is to create Arduino code, which uses a computer language called C, which is what we've talked about. C is the language that Arduinos use. And I want your code to run the traffic lights according to the following rules. So this paragraph right here describes what the traffic lights should do if nobody is pushing either one of the buttons. So if that's the case, then the lights should rotate through green, yellow, and red, okay, the way that a normal traffic light works, okay? And so what would happen here is that the green would stay lit for 5 seconds. And then afterwards, it would go off, and then the yellow would come on. The yellow would be on for 2 seconds. And then finally, the red light would come on. Now, 1 second after the red light comes on, then the other traffic light will start cycling through the same cycle as the one that just ran. And so what that means is green for 5 seconds, yellow for 2 seconds, and then red. Okay, and so it's just going to keep on doing this again and again and again, so forth and so on, as long as nobody is pushing either button. So you need to write the code for the Arduino to make it do this, provided nobody's pushing the button. But what do we do if somebody is pushing the button? So the idea here is that the person pushing the button is presumably the blind person. So they're going to push the button when they want to cross the street. Now, some of you might say, but wait a minute, Mr. Hendricks, if they're blind, they're going to have trouble finding the button. So to that I reply, Well, it doesn't have to actually be a button. It could be a sensor of some kind. You know, when you go into a grocery store, as you walk up to the door is automatically open for you because there's a sensor there. So what we could do is we could put a sensor like that. And so if anybody is standing at the signal light, whether they're blind or not, the sensor would see them and the sensor would automatically activate the button. So it doesn't actually have to be somebody physically pushing the button. But in our case, that's the way we're going to do it. Okay, so if somebody is pushing the button, then the thing that's going to be different is we want the green light to come on for 10 seconds rather than just 5, because we're assuming that the person who crosses the street, they're going to need a little extra time to cross the street, especially if they're blind. Okay. Now, one other very important thing is if somebody is pushing the button, then when the green light comes on, I also want the buzzer to beep. Because remember, blind people, they can't see the lights. They don't know whether the light is green or red. So we need some sort of a buzzer to tell them. All right. So when the buzzer starts beeping, then the blind person knows that it's safe to cross the street. Okay. Now the beep pattern, I want it to be very specific. I want it to come on for 0.2 seconds, and then I want it to be off for 0.8 seconds. And so it should just repeat that. So that means that during this 10 seconds that the green light is on, the buzzer will buzz 10 times. Okay, then after it's done 10 times, presumably the person has crossed the street. Okay, so then the yellow light will come on for 2 seconds, and then the red light will come on just the same as normal. Okay. All right, now I'm seeing somebody typing a question, but okay. All right, so the question is, so the lights are for the cars or for the people? Well, they're both, okay? It can be for both. So when the green light comes on, that means that it's safe for the cars to go. But now I'm assuming that the blind person is not going to cross the direction. Okay, so I'm assuming that if the blind person wants to go this way, when the green light comes on, that's the green light for the cars that are going the same direction as the blind person. Obviously, we don't want the blind person to go the other way. And by the way, that leads me into the next thing. One thing that I think is important is that the pitch, you know, the musical tone, the beep versus beep, okay? For the buzzer, we want it to be different for one light signal than we do for the other. And I don't know if you guys have ever been downtown where they have those special sound light signals, but that is the way that they work. I mean, if you're going north south, you have one kind of a beep, and if you're going east west, then you have a different kind of a beep. Okay, so we want to do the same thing. The beep for the signal on the right, we want it to be a different musical tone. All right, so because, let's see, let me come down here. All right, so because we are not meeting in person, I can't give you a real Arduino. So this thing right here, this is a real Arduino, and I have a whole bunch of these. I have like 30 or 40 of these. If we were meeting at school, you would be working with a real Arduino. But obviously, that can't happen. Sorry about that. And by the way, that wasn't a COVID cough. All right, so that can't happen. So what we're going to do instead of working with real Arduinos is I've got an Arduino simulator that runs on the internet, and it's amazingly powerful. It's really cool. So I used the Arduino simulator to create the circuit above. So if you click on this link that you see, what's that? Did you have a question? All right, if you click on this link right here, it'll take you to a copy of the circuit that I have prepared for you. But before we click on that, what I want to do first is I want to click on a circuit that has been programmed the way that I want it to run. Okay, so this is an example of what your program should do when you have successfully completed it. So, okay, when you open up the program, you're going to see up in the upper right here, there's this button that says Start Simulation. And that is what's going to basically power up the Arduino. And so let me do that right now so that you can verify that I've got this thing programmed right so that it works correctly. Okay, so what I'm going to do now is I'm going to click on Start Simulation, and I want you to watch and see if it does what I said to do. Okay, now it's a little bit hard to see here. Let me zoom in a bit. Let's see if it works right. Okay, we're looking at the green light right now. And okay, so it just went to yellow and it just went to red. So while that one's red now, this one is green. So it's green for 5 seconds, then it switches to yellow for 2 seconds, now it goes red. Okay, so now we're back to here, green for 5 seconds, yellow for 2 seconds, and then it goes red. Okay, and then we switch over here. So yep, it looks to me like everything's working right, at least if there's no pedestrians waiting to cross the street, it's working right. But does it work right if a pedestrian is waiting to cross the street? Okay, so I'm going to come down, I'm going to push this button right here. Notice when I push the button, the blue light comes on. Look at that. You guys hear the beep in there? Okay, all right, so you see when I pushed the button, then the light behaved differently. All right, and notice when I push the button, it goes blue, and when I let go of it, it stops being blue. So in order for it to work right, it has to be pushed when the green light first comes on. Okay, so I'm pushing the one on the left. There it goes. And now I can let go of the button. Okay, so that one is working right. Let's turn this one on while we're waiting for the light to change. Okay, the light is changing. The button is okay. There it goes. Let go of it. Okay. All right, now it goes yellow, now it goes red. And now this time I'm not pushing the button, so it goes back to the normal sequence that you get when the button is not being pushed. Okay, so you can see that this circuit that I've got here, it does exactly what it's supposed to do. Okay, so Adam is saying that he jumped out of his chair when he heard that. Okay, good. All right, so your job is to create a circuit that does this. Now, let me show you what you are going to see when you go into it. Now, in order for this to work the way that you would see it, I need to log out of my Tinkercad account. So hang on a sec while I log out. Okay. All right. So this right here is the button that allows you to log out. Okay. And I'll even go ahead and close it up. Okay. So what you guys are going to do is you're going to come on here. And so remember where we are here. So we're on Canvas right now. And we're going to scroll down to here. Okay. And so what you're going to do is you're going to click on this link right here. When you do that, it's going to open up a window that looks like this. And it's going to say that what we're trying to get into is the design that's made by D. Hendricks, yours truly. Okay. And so you can make a copy of a circuit that I've made up. So this circuit that you see, let me turn on annotation here. The circuit that you see right here, it has all of the hardware, but it does not have the code because I want you guys to create the code, not me. All right, so when we click on this button right here, then it's going to ask us to create a Tinkercad account unless we already have a Tinkercad account. So let me ask again in the chat box, can you guys please type in how many of you, have any of you used Tinkercad before? So type in yes if you've used the program called Tinkercad. Okay, so it looks like none of you have. Okay, so if you have never created a Tinkercad account, then it's going to take you to this page that you see right here. and it's going to ask you to create an account, and it's going to ask you a whole bunch of questions. You're going to have to enter your email address, and you're going to have to tell you what your birthday is. The reason for the birthday is just to confirm that you are more than like 8 years old. Because if you're a young child, then for some reason they don't want you to use the system here. But okay, so you guys will create an account. Now, I'm not going to go through that because I already have an account. So I'm going to sign in, but I'm not going to sign in with my usual teacher account. I'm going to sign in with a special student account, so that what you're going to see here will be very similar to what you would actually see when you log on. Okay. All right. So now it brings me back to here. And now I'm logged in as a student. So when I click on this, it's going to open up something that looks exactly the same as what we saw before, but it doesn't have the computer code in it to run it the right way. So sometimes it takes a few seconds to open up. So let's just be patient. Okay, there it is. Right now, first thing you're going to notice is that I've got a bunch of comments on here. And so let's look at these. Okay, so the comment on top says, obviously the code that I've entered here doesn't even come close to meeting the requirements of the functional specification. To which you say, code, what code do you mean? Well, let's click on this button that says start simulation, and let's see what happens when we start this. Okay, so here we go. So let's see what's happening. Okay, yeah, something weird is happening. So what's happening here is only one light is coming on, and then the buzzer is buzzing every time the light comes on. I wonder what would happen if I push this button right here. Oh, hey, look at that. When I hold this button down, then instead of the green light coming on, the red light comes on. When I let go of the button, it goes back to the green light. Hold the button down again, goes the red light. Okay, and let me kill this. Okay, there. Yeah, that buzzing was getting pretty annoying, wasn't it? Okay. So what I've done is, on this sample file that I've given for you, I put in a little bit of code, but obviously not the right code, because it doesn't do what I want it to do. Or at least what it doesn't accomplish the goals of the functional specification, is a better way to say it. Okay, so right here you can see a comment that basically tells you if you hold down the left button, then it changes which light blinks, and it also changes the pitch of the beeper. Okay, so this thing here basically just tells you in writing what I've already told you verbally. Right, so once you've read the comments there, if we want to get rid of the comments, if you click this button here, it makes the comments go away. All right, so what we have here is the hardware, but the code is not the right code. Well, how can we see the code? How can we get access to the code? Well, I see a button that's labeled code. I'm thinking there's a pretty good chance if I click that button, then maybe I'll be able to see the code. So let's see if that works. Hey, sure enough, there it is. There's the code, and part of it's hidden here. So I'm going to come over here. I'm going to drag it out. So now I can see it a little bit better. And what we see are drag and drop blocks, exactly the same kind of blocks that you had with that Angry Bird thing from the code.org activity, except they're more complex this time around. We're doing a lot more than just moving forward and turning right. What we're doing here is we're turning things on and turning things off, right? So let's take a look at this code here, and let's see if we can figure out how this code works. All right, so the first thing that we see in the code is we see an if statement, and we say to ourselves, oh, I remember if statements. Okay, so this thing right here, this is the test that we're going to test on. So you'll notice it says read digital pin 2. So what that means is we're going to look at what is plugged into, we're going to look at the wire that's plugged into pin 2, and we're going to look to see, is there electricity on that wire? So in other words, is the user pushing the button? Okay, so if the user is pushing the button, then pin 2 will equal the number 1. So this thing right here is either 0 or 1. So 1 means that it has electricity on it. 0 means that there's no electricity on it. So what we've got here is we're saying if there is electricity on pin 1, then we will do everything that's in this block right here. Everything up to where it says else. You see how right there it says else? Okay. So if there is electricity on pin number 2, then we will do everything that's in here. But if there is not electricity on pin 2, then we will not do this. And instead, what we will do is everything down here. Okay, does that make sense, everybody? So I need some feedback here, guys. Please type into the chat box, say, yes, this makes sense so far, or if it doesn't make sense, please type in no. All right, okay, good, making sense, everybody. All right, so now let's take a closer look at how do these things work. Okay, so let's see if I can zoom in. Hang on while I have to make this zoomable. Okay. No, it looks like it's not going to let me zoom in any more than I'm already zoomed. Oh, there it goes. Okay, now I can zoom in more. Okay, so hopefully you can see this a little better now. Let me turn the annotation back on. Okay, so if there is electricity on pin 2, then this is what we're going to do. We're going to do all this stuff right here. So you see what it is we're going to set pin number 5 to high. So what that means is we're going to turn on the electricity to pin 5, and pin 5 is connected to one of the lights. Now, in addition to turning the light on, we're also going to play the speaker. And we need to tell the Arduino which pin the speaker is plugged into. And you can see right now we've got it on pin 7, but it doesn't have to be, or I'm sorry, pin 11 is what I meant to say. It doesn't have to be pin 11. If we click right here, you see how it brings up these things? So if I wanted to plug the speaker into pin number 1, okay, I could do that, okay? And now it kind of shifted. Okay, so now it's going to play the speaker on pin 1, but this would be a bug because right now I don't have the speaker plugged into pin 1. I've got the speaker plugged into pin 11. So I better go change this back to pin 11. Okay. All right. And it looks like it shifted everything when I did that. So I'm going to have to clear this. Okay. So, and again, okay, boy, it does not want to play nicely here. Okay, well, too bad. We'll just have to go with this. All right. So, okay, so we've turned on whatever is plugged into pin 5. And we've turned on the speaker, which is plugged into pin 11. Now this tone here, you can see we've got tone 60, or we could play tone 50, or I could play tone 50, or tone 70. So this is just a code that tells it what musical note we want it to play. So if you just plug in different numbers there and experiment with it, you'll see how it works. Okay, so this thing right here, this tells us how long we want it to play that musical tone. Okay, and then this command right here says we want it to wait for 1 second, and then we're going to take whatever is plugged into pin 5 and we're going to turn it off. We're going to deactivate. We're going to turn off the electricity to pin 5. So up here, this is when we turned on pin 5, and down here is where we turned off pin 5. So whatever we got plugged into pin 5 it'll come on, but it'll only be on for about 1 second or maybe 1.5, depending, okay? So the thing that we got plugged into pin 5 right now, it's a light, but it doesn't have to be a light. It could be a motor, or it could be a buzzer, or it could be a whole bunch of other stuff. The code, the software code doesn't care what's plugged into pin 5. All it does is it just turns on pin 5. Okay. All right. And you can see now we have reached the end of the, so we've come to the else. So that means that everything up here, this is the stuff that we do if the button is pushed. But if the button is not pushed, then we don't do that. And instead what we do is we do the down stuff down here, which works the same way, except you'll notice this time, instead of turning on pin 5, this time we're turning on pin 7. And instead of playing this musical note, we're playing this musical note. But other than that, it's the same. Oh, and there is one other difference. Okay. Up here, what we do is when we turn on the light, we leave it on for 1 second before we turn it off. Whereas down here, when we turn on the light, we only leave it on for a half of a second. Hopefully you guys realize 500 milliseconds is equal to 1/2 of a second. Okay, I trust you guys know that. All right, so you see how this works here? Hopefully this makes sense to everybody. Okay, so let's, okay. So let me ask again, everybody, please type into the chat box, yes or no. Yes, does that make sense? Okay, good. All right, good. Okay, so now what I want you guys to do for your homework tonight is I want you to take the code that I have created and throw it in the trash can. You see that little trash can down there? Okay, so take my code and throw it in the trash can. I want you to create your own code. All right, so how could we do our code? So, well, the first thing we need to do is we need to figure out what is the job that we want to accomplish. All right, so somebody suggests something. So Valerie, I'd like you to turn on your speaker and I would like you to tell me which light do you want me to turn on and how much time do you want me to leave it on before I turn it off? So we've got the group over here on the right and the group over here on the left. So Valerie, which group do you want? Do you want the group on the right or do you want the group on the left?
Let's do the group on the right.
Okay, all right. Now, of the group on the right, which light do you want me to do? Do you want me to do the green light, or do you want me to do the yellow light, or do you want me to do the red light?
The yellow light.
Okay, so Valerie wants the yellow light to come on. And Valerie, how much time do you want it to be on?
2 seconds.
How much?
2 seconds.
Okay, 2 seconds. All right. Okay, so Valerie has just written my functional specification for me. All right, so what I'm going to do then is I'm going to click on code. And right now you see my code is completely gone because I completely got rid of it. Okay, so what we're going to do is you'll see over here we have a whole bunch of different drag and drop blocks that we can pull in here. Okay, so what I'm going to do is I want one of the output blocks. So I want this block right here. So I'm going to put, let's see. Well, let's do this block here. This is a better block. Okay, so I'm going to do this block that says set pin whatever to whatever. Oh, it just occurred to me before I do that, I'd better figure out which block we want. Okay, so Valerie wanted us to turn on. Okay. Valerie, can you mute yourself again? Or maybe it's not you. Here, I'll mute you. Okay, I'll mute everybody here. Okay. So first thing we got to do is we got to figure out which block or which pin we want to turn on. Okay, so this was the light that Valerie wanted me to turn on. So if I follow this line up and over and down, looks to me like pin number 9. Pin number 9 is the one that's plugged into. Okay, good. Now that I got that, okay, so let's go ahead and open up the code again. And let me zoom in a little bit, just make it a little easier here. Okay, so I want to set pin 9 to high. Now my options here are high or low. So if I want to turn it on, then high is the option that I want. Okay, so let's see. I want to, now I can't zoom back out. Why will it not let me zoom out? Okay, hang on a sec. Oh, rats, it won't let me zoom out. Interesting. I got an interesting problem here. My computer
You
won't
can press
let me.
control. You can press control and then the wheel turn on the mouse.
That not doing what I want here.
Here, no. Go to that one. Like put your mouse and now press control.
Yeah, I'm
and
doing
scroll
it.
out.
I'm
Yeah.
doing it.
Not
See
working.
that? Not working.
You might be able to go
Let
into
me just
settings.
Let me just refresh the screen. That shall do it. Kind of slow here. That's one thing about Tinkercad is sometimes it's kind of slow. Okay, so let me zoom back here. Okay, and let's go. Let's open up the code and let's drag it open a little bit more. Whoops, not that, this. Okay, all right. Okay, so you see here we've got pin 9, we set it to high. All right, now Valerie said that she wanted me to leave it on for 2 seconds. So I need a new set of blocks here. So I'm going to click on the control. And so now these are all the blocks that are associated with control related things. And you can see the first one there is the wait command. So I drag it over here. Now the default is 1 second, but that's not what Valerie wanted. Valerie wanted 2 seconds. So if I click on here and type it, okay, so there's 2. All right. So now after 2 seconds, now I want to turn the light off. So I got to go back here to my output things, and I'm going to come back in with this. And now remember, pin 9 is the one that we're working with here, not pin 2, pin 0. Okay, but we don't want to set it to high this time. We want to set it to low. And now here's something that may not be obvious. I need to put another wait command in there. And so let's say I want to wait for 2 seconds. Okay. And you're going to find out in a minute why we need that. Okay. And now what the Arduino is going to do is it's going to run this code. And when it gets to the end, it's going to jump back up the top and it's going to run it again. And it's just going to keep doing this code again and again and again and again. All right. Now let's see if that works. Let's hide the code. And let's hide all these comments because I don't like the comments. Okay. And let's come up here so we can see. All right, now I'm going to start the simulation. Let's see if it works. Okay, on for 2 seconds, off for 2 seconds. On for 2 seconds, off for 2 seconds. Hooray, it works. Okay. Now, let's see what happens if I leave this guy off on the bottom there. So this wait command at the bottom, let's drag him down to the trash. And let's close the code and let's try the simulation. Watch what happens. So it comes on and it never goes off. And we say, wait a minute, I know for sure I told it to go off. Let's go back and look at the code. Yep, you can see I definitely told it to go off. And yet, when I run the simulation, it never goes off. Can anybody think of what's happening here? Why is it that the thing never appears to go off?
Can I say?
Yeah, go ahead.
Because I think it defaults to 0 seconds if you don't put anything, so then it just never turns off because you're telling it to turn off for 0 seconds.
You're almost there. You've almost got it. Okay, what happens is the Arduino runs really, really, really fast. Okay, so what's going to happen here is the Arduino is going to see this command and is going to turn the light on. Okay, the Arduino is going to wait for 2 seconds while the light is on. The Arduino is going to see this command and it's going to turn the light off. But like I said, the Arduino is super, super, super fast. So as soon as it turns off, it immediately jumps back up here again, and it sees an on command. So what it's going to do then is it's going to turn the light back on again. So that the amount of time that the light is off is like about 1 nanosecond. Do you guys know what a nano whatever is? Okay. Do you know what a millisecond is? A millisecond is, and let me clear this up. So a millisecond is 1/1000th of a second. A microsecond is 1/1,000,000th of a second. A nanosecond is 1/1,000,000,000th of a second. Okay, so what's happening here is when the Arduino sees this, it does in fact turn the light off, but then 1/1,000,000,000th of a second later, it turns that light right back on again. So it goes off and on so fast that humans can't perceive that. We just, the human eye just cannot see something that happens that fast. Okay. All right, do you guys see how this works? Now, what if I wanted to put an if statement in here? So tell you what, if I want to bring in an if statement, let's see how that works. So I want to know if the button is pushed. So first thing I got to do is I got to figure out which button. Okay, so let's take a look at the code here. So this button right here, well, actually, that's not the button we want. I mean, we could do that, but how about if this is if this over here is the traffic light that we're interested in, then this is the button that makes sense to program. I mean, if we wanted to do that, we could, but then I think our poor pedestrians would get really confused if we did that. Okay, so let's follow this line in and let's see where it connects. Okay, so it looks to me like it connects in pin 3. All right, so now that we know that pin 3 is our input pin, then okay, so let's look at our code here. So what we can do is we can say if, and then we bring in one of the math variables here. So let's bring in this guy right there. And then we need to have some sort of a test. So we come to the input things. And you see one of our input things is read digital pin whatever. So if I put that in there, okay. So what this is telling the Arduino is saying, if this is true. So what it's going to do is it's going to look to see what it sees on digital pin whatever. And then we're going to say, well, that's not the right pin. Pin 0 isn't the pin we wanted. We wanted it to be pin 3. So let's click here and go to pin 3. And then this one here, we don't want to test if it's less than. We want to test if it's equal to. And then remember that the code here for Arduinos is if there is electricity on here, then it's going to return a 1. And if there's no electricity, then it's going to return a 0. Okay, so what we've just done is we've said, if there is electricity on pin 3, then it will do whatever we stick in here. So let's stick something in there. Let's take this guy right here and let's stick it in there. And we better have a wait here. Okay. All right, so I've got it now. So pin 9 will come on for 2 seconds, and then it'll only go off for 1 second, which is okay. All right. But we need to have something that it does if the button is pushed. So how about, let's say that if the button has been pushed, then what I want to do is I want to set a different light. So let's have the different light be the whatever is plugged into pin number 8. Okay. And we want to turn that on. And then we want to wait for some amount of time. So let's say that we only wait for a half a second. Okay. So I could put in 0.5. That would work. Or if I wanted to put it in terms of milliseconds, I could put it in as 500 milliseconds. Either way works. Okay, so then after it has been on for 500 milliseconds, then what we want to do is we want to turn it off. So we want to turn pin 9. Oh no, not pin 9, sorry, pin 8 is what we want. We want to turn it off. Okay. And then we probably better put in a delay time there, because otherwise we're going to be have troubles. And let's say that I only want it to be off for, oh, I don't know, maybe 200 milliseconds. Okay. All right. Let's see if our code does what we want it to do. So I'm going to hide the code here. I'm going to start the simulation going. And so I see the light is coming on pretty quickly. Now let's hold the button down and see, oh, hey, look at that. Yeah. Okay, so I get different patterns depending on which button is pushed. Okay. All right, so you guys see how this works? So type into the chat box, yes, this makes sense, or no, I'm still a little bit iffy. All right. Okay, good. All right, everybody seems to think that it makes sense. Glad to see that. Okay, so your assignment for tonight is just to play with this. Okay, I don't have anything special that I want you to accomplish. Just do something cool. And so maybe turn on some lights for a while, you know, have different patterns, blink. Try the buzzer. Don't forget the buzzer. Oh, well, tell you what, let's go in really quickly. We didn't do the buzzer here. So let me change our thing so that our code here, let's get rid of all this. And let's say that instead of that, let's say that I want to turn on the buzzer, right? So the buzzer is located right here. Okay. So, and we need to know what pin the buzzer is connected to. So the buzzer is connected to pin 11. Okay. And we've got a couple different tones to choose from. I'll just go with the default. So we'll play the buzzer for 1 second. And then what we'll do is then we'll just wait for 1 second. All right, let's try the code here. So look out, guys, because we're going to hear some buzzing right now. So here comes the simulation. I'm going to start it going. That's pretty annoying. Okay. Now you'll notice that the buzzer didn't stop there. That's really weird. I wonder why the buzzer didn't stop. So we better figure out why the buzzer didn't stop. Okay. Yeah, so something's going on funny with our code there. So let's try just playing it for 0.2 seconds. So I think the problem was that our wait time here was equal to the buzzer play time. Okay, so now we've got their buzzer playing for 0.2 seconds. We're going to wait for 1 second. Okay, so let's hide the code and let's see if that works better. So get ready. Here comes the buzzing again. Ah, much better. Yes. Okay, so if I don't push the buzzer, or if I don't push the button, I get that. If I do push the button, then instead of the buzzer, I get the light blinking. So yay. All right. So we have accomplished something hopefully cool. All right. So guys, your job is just to play with this. Do something cool with it. Now, after you've done something cool with it, I want you to share your creation with me. So there's one last thing that I need to show you. And then that'll show you how you can share your creation with me. So let's go back into here. All right, so let's say that we now have a cool creation. And so we like what we've got and we want to share this with Mr. Hendricks. All right, now some of you might be tempted to just copy the URL that you see at the top here and then just send me a copy of that URL. That will not work. If you do that, I will not be able to open up your circuit because your circuit is privacy protected. So what you need to do if you want to share this with somebody else is you need to come over on the right here. So you see where it says share over on the right? So you need to click this button that says share. And then you'll see you have two options. One is to download a snapshot of your design, which there's no sense in doing that. The other one is to invite people. Okay, so I want you to click invite. And now here is a link. So if you click the copy button, it copies this link to your clipboard. And so now if you submit that to me, then it will give me a copy that I can then have access to. So remember, do not just send me the URL that you see up at the top. Use the share button and use the invite people. This is the link that you need to send me. Okay. So after you get your circuit so it does something cool, then send it to me. Now on Canvas, I don't yet have it set up with an assignment. So if we go into Canvas, I don't have an assignment set up right now where you can submit it via Canvas, but as soon as we finish up this class here, I will. I will go into Canvas and I will create an assignment that basically just says, submit something cool. And so you've got until next time we meet in order to do that. So there's not one here right now, but there will be. In fact, let me do it right now while you guys are watching. I'm going to add an assignment, and the assignment is going to be submit something cool from the Arduino simulator. Okay. And so there it is. Okay, so now there is an assignment on Canvas. So when you click on that, then you will be able to submit the link to me. And bingo, we're done. Now, I do want to have that by the next time we meet. So the question now is, when is the next time we meet? So, you know, this A-B schedule. So Friday is technically a B day, but we're not going to officially meet on Friday. So the next time that we're going to meet together as a class will be Tuesday of next week. So by Tuesday of next week, I want you to submit something cool. So I'll let you decide what it means. What something cool, what does that mean? I'll let you decide that. Are there any questions? Not seeing anything, not hearing anything. Okay, so before you leave, please type bye into the chat box. Remember that the class is not over. We still have some class time left. You guys, please use this time to get working on the assignment. I will see you guys later. I'm going to go ahead and end the recording now.
Thank you.